Welcome everyone to where we are putting together solutions for students who are getting problems in primary school math. And we'll be looking today at the secondary entrance assessment, the SCA, specifically the year 2023. And because students are getting so many problems, this video looks at section 1 of that paper. Don't forget to like the video and add any comments down below so we can help by making other explanation videos for you in any areas that you are struggling with. Remember, we also have channels for Form 5 CXC Math and also for CXC Additional Math. And you can get them in the links down below. So let's now move on, and we're going to look at how in this section 1 of the paper, the way the questions are distributed. Remember, there are 4 strands in primary math, and number takes almost half of all the math content. So for section 1, which has 20 questions, then numbers 1 to 10, half of them will be on the strand of number. And the next strand will be measurement, which takes the next 4 questions, which are 11, 12, 13, and 14. And the last 6 questions in section 1 are shared between geometry, 3 questions for that, 15, 16, and 17, and statistics, 18, 19, and 20. So that covers the 20 questions in section 1 in this 2023 paper. So now let's move on and actually look at the questions. So number 1, which will be under the strand of number, write the numeral 91005 in words. And some students can immediately write the answer, and that's fine. If you know it, stop the video, go write the answer, and then come back and look at the explanation, and do that for each one of the questions as we go through it. So some teachers help remind you that you want to draw a little place value chart, and in that we'll put our ones and then tens, and what comes next? Hundreds. And of course, math is patterns. So what comes after ones and tens and hundreds? Ones and tens and hundreds. And what do you think would come next? Ones and tens and hundreds. And they're repeated because we know math is patterns. So there's a family of ones and tens and hundreds, and that is a family. They form the family of ones. And the next 3 will form another family. And what is the name of that family? Thousands. And if we had the next 3, ones and tens and hundreds, that would form the family of millions, and going on and on. So let's see if we could put the numbers that were given above. So the numeral 9, if you notice, is the 5th place, and then 1, 0, and 0, and 5. So let's recognize that the 9 and 1 is in one family. So if we think about that family, which has 9 tens and 1 1, then what is 9 and 1? Then that is said to be 91. And 91 what? What's the family's name? 1,000. So it's 91,000. And then, do we have any hundreds? No. Do we have any tens? No. We only have 5 and 5 ones. So how do we say that? And 5. 91,000 and 5. So let's go on to number 2, where in this question, they ask us to arrange the numbers below in descending order. So the numbers are written right below it, but I moved it to the left-hand side to show us a little way of doing some explanation. So there are actually four numbers: 3162, 3612, 3216, 3126. And sometimes when students are trying to arrange this in order, in this case, descending order from largest going down, that's the descend, to the smallest, sometimes they get confused. And when we look at the answers that students put for the SEA, we will see some level of confusion is happening. So let's sort of clarify this. Of course, there are some students who will write the answer immediately. We just want to go through a little way of reasoning out what is happening. So if we consider what we did just now, which was come up with a little place value chart, then we know we have ones, and then tens, and then hundreds. And of course, it's ones and tens and hundreds and so forth, but there's only a fourth place. So we could write it as normal, which is thousands or 1,000. So now that we know that, can we represent those numbers in this chart? Of course. So instead of writing the 3 and the 1 and the 6 and the 2, the numeral itself, which is obvious there, let's do it a little differently. Let's consider how many thousands are there in the first number. There's 1, 2, 3. And let's not worry about the rest of the number. Let's go look at the second numeral they gave us. How many thousands are there? 1, 2, 3. So they're the same. We can't tell which one is larger or smaller by just looking at the thousands for the first two. What about the third one? 1, 2, 3. And then what about the fourth one? 1, 2, 3. So if we're looking at thousands alone, all of them are the same. We can't tell which one is larger or smaller. But it helps us with certain things. So if we think of putting a little number line to show us, well, the numbers are somewhere between 3,000 and 4,000. Anywhere in there, all four numbers lie. And if we think about that, what's the middle of 3,000 and 4,000? Right? Let's put a benchmark. The middle would be 3,500. So it gives us a little idea of what the value is. So now we've finished with the thousands. Didn't give us too much help. Let's go look at the hundreds. So in the first number, 3162, how many hundreds are there? There's 100. What about in the second number? There are 1, 2, 3, 4, 5. Can I put them together? And one more, 6. You can write it like a tally chart if you wish, just to give you an idea. So clearly here we can see that even though the thousands were the same for all of them, the hundreds are different, and we can tell one is larger than the other. Let's go look at the others. In the third number, how many hundreds are there? 1, 2, so there are 2 hundreds. And in the fourth number, how many hundreds are there? There's just 100. So immediately at this point, even though all the thousands are the same, we can see just by the size of it that there are 6 green strokes in our second number, which means that is the largest number. So we know we've gotten the first one in, that when we're writing our largest number, it's 3,612. We're sure that's the largest one. And if we think about our number line, where will 3,600 be? Will it be above or below 3,500? Well, let's highlight that to make sure we know we've knocked out this whole row already. We've knocked out that number. And if we put it onto the number line, we could see that it's above 3,500. All right. So now that we've done that, let's now look at the other 3 numbers. 3 of them, one has 100 on top, the third row has 200s, and the fourth row has 100. So we can easily see that, look, the 200 is more than the 100. So we know what comes next. And if we put it on the number line, we go in 3,100, 3,200, and we can continue 300, 400, and we have 500. So we know that 3,200 is the next largest number. So we've gotten the first largest number, and we're going in descending order. What's the next largest number? 3,200. And where does that fit on our number line? Is it below 3,200, less than it, or more than it? If it's more, then it's going to appear, which part? Above it. So we've knocked out, we have two yellow rows to indicate we've knocked out those two numbers already. Now we're just left with two numbers, right? Both of them have 3,000, both of them have 100. So what do we look at now? What actual values that we're looking at? Let's go look at the second one, which is tens. So how many tens does the first number have? 3,106 tens. And if we look in the fourth number, right? Oh, let's put in the others as well. Well, we know this 3,610, even though that's already knocked out, we knew it. And for the third number, it's also a 1, right? Just to complete it so students could follow. And for the fourth number, it will have two tens. 1, 2. So if we're comparing the top row and the bottom row, which one is more? We can physically see that the 6 tens is more than the 2 tens. So therefore, 3,162 is the next largest number, right? And noting that, let's look at the number line. Is that 3,162 just above 3,100 or close to 3,200? So we could put it there, a good bit there, 3,162. And of course, what we're left with now is the last number. And we have our numbers arranged in descending order. We can complete it by putting in the number line. You'll see 3,126 below 3,162. And if we want, we can put in the ones just for you to see it. 2 ones in the first, 2 in the second, 6 in the third, and 6 in the fourth. So sometimes if we look at the numbers alone, we may get confused, but maybe this place value chart can give us an idea. Let's go on. We've handled number 2 now. Let's go and look at number 3. In this question, they're asking us to write 2 3/8 as an improper fraction. So let's consider, when we're talking about that, we can represent it in many different ways, the idea of fractions. So simply, some of us could watch it and know the answer is 19/8, and that's great. Remember I said that throughout this explanation, whenever I bring up the question, if you can pause it, work it out, and come back and check. What I'm doing is giving a bigger explanation in terms of it. So we can represent a whole as a circle. We could use any shape. And what is important? That whole is to be broken up into how many parts? Well, what tells us that? The denominator, the number below. The number below tells us that we're breaking it up into 8 parts. So if we think about this, if we draw a line straight down the center, we'll cut it into 2, and we draw across, like north, south, east, west, we'll cut it into 4, and we could split it up into 8. So now that we did that, one whole, let's shade the entire thing, will give us what? How many parts? 8 parts. So I'm going to do a little counter on the side here to keep track of it. 1, 2, 3, 4, 5, 6, 7, 8. 8 parts made one whole. And if we look at the improper, the mixed number up on top, we had how many holes? We had 2 holes. So we already catered for one hole. Let's go do it again for a second one. So that second hole will have how many parts again? 8 parts again. And we're taking the entire of that second hole. So that's another, how many parts? 8 parts again. And if we want to keep count, for those who want to like the idea of the tracker on the left side, then if we had 8, we're going to add 1, 2, 3, 4, 5, 6, 7, 8 more parts. So the two wholes will be 8 parts and another 8 parts, which is how many? 16 parts. Are we complete with the mixed number? Well, we've catered for the two wholes. Now we just have the proper fraction, the 3/8. So that proper or common fraction, we still have to represent it. Look at a whole. We're going to break up the whole into how many parts? 8 parts, because this entire question is dealing with a denominator of 8. And how many of those parts are we taking? Are we taking the entire circle? Or are we just taking a portion of it? Well, let's see. If you look at the numerator, the number on top, it tells us how many of those small parts we're looking at. We're looking at 3 of them. So let's shade that. I'll use a different color. So that means we have 3 more parts. So let's go add it to the counter. 1, 2, 3. So we're totaling 8 and 8, 16 and 3 more, 19 parts of those, what was represented as 8s. So it's 19 out of 8, or 19 eighths. So some teachers like to do it like this, 2 and 3/8. Well, students, what do we know? We have 2 wholes, and each whole has how many parts? 8 parts. So that means if we cater for the 2 wholes, it will give us 2 times 8, which is 16 parts. You could see it in the diagram below. You could see it on the counter on the left-hand side. And when we get that, let's work that out first. 2 and 8, that'll be 16. What do we have to do? We have to add what remains, which is 3 more parts. So we have 16 and 3. It's 19 what? 19 eighths. So that's how we come up with the answer of 19 over 8. All right, so we've just converted a mixed number into an improper fraction. Let's move on. Let's go look now at number 4. And if we're looking at number 4, the question says divide 628 by 12. So normally teachers advise us, let's go write this long division. We have the divisor, which is 12, which is on the outside, the dividend, which is 628 on the inside, and we have to find the quotient and if there's any remainder. And for some, you can pause it and go work it out if you're okay with it. And for others, we're a little bit cloudy about what's happening. Let's see if we could break it up. So how much do we have in all? We have 6 hundreds, 2 tens, and 8 ones. So let's represent that. Remember that you've been doing your base 10 blocks with your teachers, and each one of these squares are 10 across by 10 down. 10 tens are 100. So we have 1, 2, 3, 4, 5, 6. So we have 6 of those squares representing 600. And then we have 2 tens. So we could pull out a rod of 10 and another rod of 10. So 2 tens are 20. And of course, 8 of those units, 8 to represent 8 ones. So this tells us 628. Now, what does that 12 is asking us to do? It's asking us to first of all go and look in the hundreds. We have 6 of those. Can we form a group of 12 in it? Well, we only have 6, so we don't have enough to get 12. Now, what do we do? Let's recall that one of those squares is 100, or it is actually, let's replace it as 10 tens. I'm going to break it up. So one of those squares became 10 tens, which is 100. And let's replace it for the rest of them as well. Another 10 and another 10. So we have 10, 20, 30, 40, 50. And we replace it again 60. And don't forget the 2 up on the right-hand side. We have 62 tens. So it was 600s. We changed those to tens. So it's 60 and 2, 62 tens. You can see it there. So we're not saying 12 into 6. Some students, they mistakenly say 12 into 6 cannot. But what's really happening is, do we have 6 squares and can we form a group of 12 in it? We cannot. But if we say, let's change 6 squares to 60 and to 62 tens, can we form groups of 12 here? Well, let's see. if we look, how many columns did we have? 1, 2, 3, 4, 5, 6. So I have 6 in the first row and 6 in the second row. So I can make a group of 6 and 6 is 12, and another group of 12, and a third group of 12, and a fourth group of 12, and a fifth group of 12. Can I make any more those? No, we can't. So how many groups of 12 did we get? We got 5 groups. That's our answer. So where do we write that? Up on top where the quotient is. So if we're thinking about tens only, we had 62 tens. And we were able to, out of those, form 5 groups of 12. And what does that mean? It means that out of the 62, we used up 60 of them to form groups of 12. And do we have any left? Well, that's why we take away. And when we subtract, look, we have 2 left. Look, it's up on the top right-hand side. So we have 2 tens left. Could we now form with those 2 tens up on top a group of 12? No, we can't. But it's not 2 tens only. We also have 8 ones. So that's 2 tens. And let's bring down that 8. That's what the teachers normally tell us to do. So we have 2 tens and 8 ones, which is 28. Now, can we form a group of 12 from the 2 tens? We cannot. So what can we do with one of the tens? We can take it and break it apart, just as we broke the squares apart to get the rows of 10 or the rods. Right? We're going to take one of those tens and break it up into 10 little ones or 10 units. And what do we do with the other 10? We can break that up as well. So now we have 28 ones. It was 2 tens and 8 ones, which is, right? It's the same as 28 ones. It's the same value. Can we now form a group of 12? Well, the first 2 columns just that we brought up had 10 already in it. So we could just add 2 more up on top. And look, we have one group of 12. Could we find another group of 12? Well, there it is. So we found 2 groups of 12. Can we find any more? No, we can't. We don't have enough. So how many groups of 12 could we get in the 28 ones? We could get 2 of those. So let's put that in the answer. So our quotient says that we got 52. 5 groups of tens and 2 groups of ones. So we have 52 of those. So we have 12, right? And another 12, which means that we used up 24. What happens now? We had 28 in all and we used up 24. So what is remaining? Well, what's remaining is 4. Can we get a group of 12 from that? We cannot. So now we're finished. We can say that out of 628, when we divide it by 12, then we were able to form 52 groups of 12 and we had a remainder of 4. So let's now go on to number 5, where it's asking us, what is the answer for 8 squared plus 6 squared? And some of us know it immediately. You can write it down, pause the video if you want, go do your working. For those who are getting problems, let's think about 8 squares. Well, it's a square. So we could draw a square with 8 sides on, right, on an 8 side on the other side. So it's 8 by 8. Now, how many is 8 times 8? Some of us know it immediately, and that's fine. Some of us get problems with the 8 times table, so let's cut it up. Let's count 1, 2, 3, 4, 5. We know our 5 times table, and let's draw a little line there. So we have a row of 5, and another row of 5, and another row of 5. How many 5s do we have? We have 8 rows of 5, and 8 5s are 40. And what do we have on this side? We have a row of 3 and another row of 3 and another row of 3. How many rows of 3? We have 8 rows of 3. So we needed our 5 times table if you wanted there on the left, and on the right side we need our 3 times table. So 8 3s are 24. So how much is that in all? How many squares is that? 40 and 10, 50 and 10, 60 and 4 more, 64. So 8 squared is 64. And let's do the same for 6 times table. I know students are very good from 1 to 5, but sometimes when it's more than 5, they get some problems. So let's look at it. 6 by 6, and we could count 1, 2, 3, 4, 5. Great. And we could draw a line again, and let's use our 5 times table, because students are very good with 5 times table. So we have one row of 5 and another row. And how many rows of 5? 6 rows of 5. Let's count them. 1, 2, 3, 4, 5, 6. Great. 6 rows of 5. 6 fives are 30. You could tell that from your watch. Right? So now we know where 30 minutes is when the hand is at 6. And what do we have remain? 6 more. So 30 and 6 is 36. So now 8 squared plus 6 squared is the same as 64 plus 36. And some of us could work it out quickly. Some of us need to do it on the side, and that's fine. Let's count the ones. We have 4 ones in the first number, and in the second number, we have another 4. So if we add up 6 and 4, well, that's 10. So we have 10 ones, right? And if we think about, we just want to put the value of the ones there from the 1 and the 0, then we could take out the value of ones and place it in our answer. And how many tens do we have left in this question? We have 6 tens left up on top in the first number, 3 tens below, that's 6, 7, 8, 9, and 1 below that. So we have 10 of them. So now we have to write the value for tens. So we could cross out that and put it there. And of course, we're left with 1. That 1 goes here. So that means what's our answer? Our answer is 100. 8 squared plus 6 squared is equal to 100. All right, let's go on. In number 6, round 15296 to the nearest thousands. So we know we have 13,000, 14,000, 15,000, 16,000, and so forth. And if we look at the number carefully, there's a space between the 5 and the 2, telling us that's 15,000. And you can put the place values, the numbers up on top, 0, T, H, and so forth. So you know it's 15,000. That tells us our answer is either 15,000 or what comes next, 16,000. And we want to round it off. So, excuse me. So which answer will it be? Will our answer be 15,000? Is it closer to 15,000 or is it closer to 16,000? Let's think about what is the middle of 15,000 and 16,000. Using that as our little benchmark, the middle is 15,500. Right? So that should help us a little bit. Where does 15,296 lie? That 200, will it be on the right of that 500 or on the left? We're going from 15,000 to 16,000, so 15,200 will be somewhere here. Doesn't matter, just a general idea. Why is that important? Because now that we know where 15,296 generally lies, let's look at the distance. The distance from there to 15,000 is represented by the black curly brackets and the red one for 16,000. Which one is it nearer to? It's nearer to the 15,000. That's why we put that dotted line there so you could see which side is closer. So our answer is 15,000 will be what it's rounded off to. Let's go on now to number 7. In this question, Max ate 5 cherries, which were 1/9 of the total number of cherries he picked. How many cherries did Max pick? So, let's think about that. Max ate 5 cherries, which were 1/9 of the total. So 1/9 of, let's put a little box to say that's the total number. 1/9 of that is 5. And if we think about it, that means Max picked a lot of cherries. and 1/9 of it is how much he ate. So let's see, let's consider, put a rectangle here, could use any shape, and say that is how many cherries Max picked. And if we cut it up, how many parts should we cut it up into? Well, look at it, 1/9. So we should be cutting it up into 9 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1/9 of what he picked is what Max ate, which is 5. Now, one of the things with fractions, when we cut up a whole into 9 parts, each of the parts is exactly the same. So the second part will be 5 as well. The third will be 5, and so forth. So how many parts do we have in all? We have 9 parts. And if each part is 5, then what's the whole? The whole will be 9 5s, which is 45. Right? So Max picked 45 cherries and he ate 1/9 of that. 9 into 45 is 5. Good. Let's go on to number 8. So when we look at this question here, write the total value of the bills and the coin shown below. So because students are so good with money, right, we could do this pretty much in our heads. We have $20. And what are we going to do? Add another 20, that's 40, and add 5, 45, and add 1. So how much is that going to give us? 20, 40, 45, $46. And is that all? No, we also have some cents. How many cents do we have? We have 5 cents. How do you write that? We represent 5 cents as 0.05. And now we just need to add. So if we're adding from the right-hand side, 0 and 5 is 5. 0 and 0, that's 0. And now what do we need to put? We need to put our point to separate cents from dollars. And we have $6. So that remains the same, and 4 tens. So we have $46.05. So we did our money question. Let's go on now to number 9. And in this question, they're asking us to calculate 15% off 120. And there are so many different ways that teachers show students, right? Let's try to show a couple. Let's look at the number line. Let's say we started with 0%, 10%, 20%. By the time we reach the end, we have all, which is 100%. So 100%, you know, represents everything. And it says that 15% off 120. That means 120 is the entire thing. So 0% means we have none, and 100% everything is 120. The whole thing is 120. So if we know that, what is 10%? 10% is if we cut this up into 10 parts. What happens if we cut 120 into 10 parts? Each part will be a total of 12. So one part, or 10%, is 12, and we put another 10%. What are we going to get? We're going to get another 12. 12 and 12 is 24. Now let's look at our question. Is our question asking us for 10%? No. Is it asking us for 20%? No. It's asking us for 15%. Where is 15%? Directly in the middle of 10% and 20%. So that means 15% is directly between 12 and 24. If each 10% we move by 12, then what's the middle of 12 and 24? Well, the answer is 18. And that's it. The question is finished. Or some teachers like to say, well, look, we have an entire block, which is 100%, and that is 120. Can we cut that up in parts? Of course. We could cut it up into 10 parts. And when we cut it up into 10 parts, each part is 1/10. So let's shade that. So that's 1/10 that we're shading. So that's telling us 10% is 120 divided by 10. It's just a different way of what we did below. So the whole thing was 120. And if we cut it off there into 10 parts, then that will give us 12. So 10% represents 12. What happens now? If we go across, we could get 10 parts cut again into 10 more. So we have 100 squares now. So if we consider 100 blocks, or 100% was 120, and 10 blocks is 12, what did we shade? 1, 2, 3, 4, 5. What is 5 blocks, or 5%? Will it be 12? No, it'll be half of that. So 5% is half of 12, which is 6. So what does that mean? How do we get 15%? 15% is 12 and 6 is 18. So a different way to do it. And of course, the traditional way, which is teachers say, well, listen, some teachers say 15% of 120. Percent means out of 100. So we're going to write 15 over 100. Off means to multiply times 120. This is how some teachers do it. So what do we know? We recognize that 100 and 120, both of them can be divided by 10. So 10 into 100, we get 10 tens in 100. And 10 into 120, we'll be left with 12. And now, can anything be divided again? Well, let's see. We can divide 10 by 2, and we can divide 12 by 2. We can form how many groups of 2? From 10, we get 5 groups. And how many groups of 2s can we get in 12? We can get 6 groups. Great. Is there anything else we can do? We can form groups of 5 from 5, and we can form groups of 5 from 15. So 5 into 15, that's 1. We got 1 group of 5. And how many 5s can we get in 15? 3 groups. So we're left with 3 times 6. And of course, the answer is 18. So many different ways, and there are so many more ways we can show this. Let's go on to number 10, where in that question, they're giving us the idea that we're going to write the digits 1, 2, 3, and 4, those 4 digits, in the squares below to create an addition problem with the largest possible sum. So if we have to do that, how do we manipulate it? If we think about place value, then there are only 1s and 10s. So 1, 2, 3, and 4 must fit in there in a way to give us our biggest possible sum. Now let's think about it. If we think of 1, 1 can either be 1 set of 10 or it can be 1 unit. What about 2? Well, then 2 could either fit as 2 10s if we put it on the left side, or it could be 2 1s. What about 3? 3 can be 3 10s, or it can be 3 1s. Because we have the options. And finally, what about 4? 4 can be 4 10s, or it can be 4 1s. Now, we have 1, 2, 3, 4, 5, 6, 7, 8 choices. Do we take 1 10 or 1 1? We can't take both because we only have 4 spaces. So we have to pick 1 from each of those columns coming down. Right? Which of these, if we want to get our largest answer, which of these will give us our largest answer? Out of those 8, the 4 10s. That means we cannot use the 4 1s because we only are allowed to use 4 one time. So where do we put that? We can place it as 4 10s. That helps us because we know the largest answer means that we're starting with 40 something. Now we can't use 4 1s anymore. The 4 has already been used up. So we either have to use the 1, the 2, or the 3. Which one is going to give us our largest sum out of those 3 and 3, 6 choices we have? Well, 3 10s. So if that's the case, We can't use the 3 ones because we're already using the 3 under the tens column. So we can place that here. And what does that mean? It means we've already used up all the tens. So we can't use 1 10 and we can't use 2 10s. So our answers are going to be 1 1 and 2 1s. And what they're asking us to write the digits in the squares below to create an addition problem with the largest sum. And that's what we did. If we want, we can work it out. 1 and 2 is 3, and 4 10s and 3 10s are 7 10s. So what did we do? We said 41 plus 32. Or we could have switched it and switch it so we get, instead of using 1 1 in the first number, we could use 42 and 31. It would still give us the same answer. Or we could even put the 3 10s up on top and the 4 below. So we end up with 4 different ways of writing this. But let's go on now to number 11, because we have finished the strand of number and we're now moving into measurement. So a part of a calendar for the month of April is shown below. So look, we have April, and this is what was given in the paper. We're starting with the 10th, that's been Monday, and going on until the 29th, right? 30th is missing, the numbers before 10 are missing. On what day of the week is the 2nd of April? Which day? Is it Sunday, Monday, Tuesday? Which one of those 7 days? So let's recall that, first of all, there's a space missing. Let's put that in. And that space would be 9. And if we look across 9, 10, 11, 12, 13, 14, 15, and so forth, and it goes into another row, what is that actually representing? It's representing a number line. So what comes before 9? 8. And before that, 7 and 6 and so forth. And if we had to put that, then let's shift it up a little bit. And where would 8 go? 8 would be which day of the week? 8 would be what comes before Sunday? It will be Saturday. So let's slide it across. So we have 8, 7, 6, 5, 4, 3, 2 on Sunday. And we have the 1 there. That shows us our number line. Remember, we could write, when we're thinking about a calendar, 1 to 30, the 30 days of April, straight across. It's just that we're accustomed to taking them in groups of 7, which is a week. And let's shift it up again, because we have that 1. I'm going to leave it on the left side, but I'm going to bring it up as well for you. Notice that our answer is Sunday. Because on what day of the week is the 2nd of April? Well, we got our answer. The 2nd of April is on Sunday. Let me just bring up that idea of the 1 across for you so you can see this is what the calendar really looks like. And they took off what was in blue and gave you the question. Right? Other ways that can be done, we can think about the idea, well, listen, our first number that was given in black was 10. And if we go back 1 week, we'll go up. Well, what does that mean? It means 10, take away 1 week, which is 7, and 10 take away 7. Well, of course, that works out to be 3. So on one Monday, it's the 10th. On the Monday before, it's the 3rd. And if we want the 2nd, we go 1 to the left. So what's 1 day before Monday? It's Sunday. And there are many different ways. Right? Remember, when you look at a calendar, if we're going across, we're moving 1 to the right, plus 1, or 1 to the left, minus 1. And if we're going up or down, we're adding 7 or minusing 7 accordingly. Right, let's move on now to number 12. And if we think of number 12 there, it says the total mass of a pineapple and a pawpaw is shown on the scale below. Now let's pause for a little bit and take a look at that scale. We have the pawpaw and we have pineapple there. And it's on a scale. So they're giving us some information here. Now that we know that, the mass of the pineapple is 2.75 kilograms. What's the mass of the pawpaw in grams? So we know certain things. Let's think about the total mass. It's somewhere between 3 and 4. So let's put a little dotted line so you can see it clearly. So what would we consider that to be? 3.5 kilograms. So remember, 1 kilogram, the word kilo, that prefix means 1,000. So 1 kilogram means 1,000 grams. So if we have 3.5 kilograms, it'll be 3.5 times 1,000. And how do we multiply by 1,000? We've shifted 1, 2, 3 places to the right because there are 3 zeros. So we know that the total mass of the pineapple and the pawpaw is 3.5 kilograms or 3,500 grams. So let's put that up there. Now, what else do we know? We know the mass of the pineapple. Since 1 kilogram is equal to 1,000 grams, the mass of the pineapple is 2.7 kilograms. So let's convert that, 2.750 multiplied by 1,000. And what do? When we multiply by 1,000, multiply by 10, 100, 1,000. Shift it 3 places to the right. So our answer is 2,750 grams. Because we want our answer in grams. We could have worked out everything in kilograms and then converted it at the end. There are so many different ways to work out every single question in math. So if total weight is 3,500 and the weight of the pineapple is 2,750 grams, what's the mass of the pawpaw? Well, we have to subtract it. And we now say 0 minus 0. Well, that's simple enough. We have 0 minus 5. But what we realize, it's really how many tens? We have 50 of those minus 5. So we could say that will give us 4. And we can carry across 1 across. So it'll be 10 of those. 10 and 0 is 10. 10 minus 5 is 5. And of course, 4 minus 7 will not be possible. So we'll have to take 1 from the 1,000 grams, right? We're left with 2,000 grams. And when we have 1,000 grams and we carry it across the hundreds, how many hundreds we're going to get? We're going to get 10 of those. So 10 and 4 is 14, minus 7 is 7, and 2 minus 2, well, that's 0. So our answer is 750 grams. Of course, you could have worked it out in kilograms only, 3.5 minus 2.75. It would have given us 0.75 kilograms, and then do the conversion. That's fine. So many different ways. Number 13, right? Identical cubes are packed into a box as shown below. Now I'm bringing them up one at a time for you to see, but it was actually given the entire shape all in one. So it had 1, 2, 3, 4, 5, another row of 5, another row, 1, 2, 3, 4 rows of 5s. And then this. So what the students saw for the SEA people was this entire shape. And they're asking, since this was made up of identical cubes, how many cubes are in the box? Now, it's difficult to see in this situation here, but you saw from the way we brought it up that there are many of those in the back that we're not seeing. So if we count it and we try to figure out what is on the bottom, what is on the base, how many of those are there on the base? Well, in the back row, and each row going across, we had 5, as you can see, 1, 2, 3, 4, 5, and another 5, and another 5, and another 5. So is there a quicker way to work out 5 and 5 and 5? Well, how many 5s do we have? We have 4 5s. So the area of the base is 4 5s are 20. It means 20 cubes will give us our base. And we have 20 cubes on the bottom layer. And we have 20 on the next layer. So the volume of the box will be how many cubes we have in all. A 20 and another 20. So that's 2 20s. So the volume of the box is 40 cubes. Okay, let's move on to number 14. In number 14, it's saying that we're going to ask you to calculate the difference in length between the eraser, which is on the left-hand side, and the pen. And let's look at the pen first. The pen is starting off at 6 centimeters. We have it in green. And by the time we're finished, it ends up at 17. Now recall that this here, we can actually think of it as we're starting a number line, and we shift the number line to the point where the pen now starts. And if we shift it down, we'll see that with the blue number line there, we have 0, it's where the pen starts. And if we're measuring to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it tells us that our pen is 11 centimeters long. If you want to do working, then it's 17 minus what it started with, 6. 17 minus 6 is 11. Let's now go, we've worked out what the length of the pen is. What about the eraser? Let's now look at where did the eraser start? The eraser started at 1 centimeter. And let's do the same thing again. Let's think of it as a number line and we bring it up. So if we say we're starting at 0 and we move across 1, 2, 3, that means the eraser is 3 centimeters long. So the pen was 11 centimeters and the eraser is 3 centimeters. We could do it by just saying 4 was the final part of the eraser minus 1. 4 take away 1 is 3. Now look, let's go back and see if we're finished. What is the question asking us? Calculate the difference in length between the eraser and the pen. So pen minus the eraser, the pen is 11 minus 3. So the difference is 8 centimeters. Right? That's the difference, meaning that the pen is 8 centimeters longer than the eraser. Let's go on now to, we're moving to number 15. The pyramid shown below has a square base. How many edges of the pyramid have a length of 6 centimeters? So let's think about this. This is a square-based pyramid. So let's identify where the square is. Right? And now that we know that's the base, remember if one side is 3 centimeters, let me highlight that in red, and it's a square, then the other side is 3 centimeters as well. And then there's a third edge, which is 3 centimeters. And there's a fourth edge, which is 3 centimeters. Now, let's look at the question. How many edges of the pyramid have a length of 6 centimeters? So it's none of those that we have in red. But look, we see a 6 centimeters here. Let's highlight that in green. We have one of those, which is 6 centimeters. Is there any more? There'll be one right in front of us, closest to us, which is 6 centimeters. That's 2. One on the left-hand side, which is 3. Is there any more? The dotted line in the back. So that is telling us that what happens, we have 1, 2, 3, 4 green lines. So we have 4 edges which have a length of 6 centimeters. Right? Let's go on now to number 16. And in this question, it's saying that the arrow below is pointing to B. And we can see that. The arrow moves 3/4 turns in an anti-clockwise direction. Let's think about that. What do we mean by anti-clockwise? Now, some of us have watches on, right? And if we are getting watches, make sure we have analog watches rather than digital. It will help us. So we have, look at how the hands move. They move from B, it would be moving to C. That's the way a clock normally moves. What direction do we want to move in? An anti-clockwise direction, in the opposite direction to our clock. So if we think about that, let's bring up a hand. Oh, let's see what the question asks. To which letter is the arrow now pointing? So let's bring up a hand. I'll have it in red. And we're going to move in which direction? Anti-clockwise. So we are going to go down or up. We're going to move up at 1/4 turn. And if we move 1/4 turn, we move from B to A. So let's look at the question again. The arrow moves 3/4 turns in an anti-clockwise direction. We started at B, we moved 1/4 turn, we're at A. Let's move another quarter turn, where we're going to end up at? End up at D. And if we move a third quarter turn, we're going to end up at C. Therefore, what letter do we now end up pointing at? We're ending up at pointing at the letter C. Let's go on. We have 4 more questions. So, in number 17, name the type of triangle shown below. So we have 5 centimeters for one side, 7 centimeters for another side, and 9 centimeters for the third side. So let's recall that there are different types of triangle. One triangle is known as an equilateral. Lateral means sides, and equi means same. So it means that all the sides of the triangle are the same. So if we have 1, 2, 3 sides, all 3 sides are the same. Is that triangle above an equilateral triangle? 1 is 5, 1 is 7, 1 is 9. No, they're not, because they are not all the same. What's another type of triangle? An isosceles triangle. Think of an isosceles triangle. What is special about it? 1, 2 sides are the same length. Iso, same. But the third side is a different length. So let's look at it. Do we have 2 sides that are the same above? No, we don't. Let's think of it a third type of triangle. There's the right angle. So the right angle, another way of saying a quarter turn. So if we have one side and we go up a quarter turn and then we complete the triangle, look at where our quarter turn is. Is this a right angle triangle above? No, it's not. And the last type of triangle that we know is the scalene triangle. And in the scalene triangle, 1, 2, 3 sides, they are all of different lengths. And if we look at it, 5, 7, and 9, they're all different lengths. As such, our answer is what type of triangle? A scalene triangle. Okay, let's go on to the last strand, which is statistics. And that will be the last 3 questions. So number 18, the table below shows the shoe sizes of some students. So look, we have shoe size 9, shoe size 8, 7, 6, and 5. And the students in the class, 11 of the students have a shoe size of 9. 3 of the students have a shoe size of 8. What shoe size represents the mode? So let's recall mode, let's spell it, M-O-D-E, means the most, M-O-S-T. So which one of those appears the most? Now, what are we talking about? They're asking us about what shoe size. So we can see easily that 12 out of the number of students, we have 11 students, 3 students, 12 students, 9 and 3. 12 is clearly the most. One of the problems, many times we see students make a mistake at this point, even though they are sure 12 is the most, because they forget that they're not asking you how many students, they're asking you which shoe size. So let's highlight that a little bit. So the answer that we can give them, what shoe size represents in mode, will either be 9, shoe size 9, shoe size 8, shoe size 7, 6, or 5. And which one is the most? The shoe size number 7. That means in shoe size number 7 in class, the most number of students were that size. Let's go on now to our next statistics question, number 19. And in this question, they're asking us to calculate the mean of the numbers below. Sometimes some people use other names for mean. Sometimes they use the word average, and that's fine. Okay, so how do we find the mean of 5 different numbers? Well, I like to draw diagrams. So let's see if we could get a diagram to show that before going to work it out. So let's put up the first number is 32, and the second is 14. The next one is 24. There's nothing for 0. And of course, there's 5. So now that we know that, this is what those numbers look like. What does the mean? What understanding do we get from that word? It is that if we can share this up equally, so they all get the same amount, that will be considered the mean. So if we look at this, 32 is very tall. So we don't have enough to give 32 to everybody. So 32 cannot be the mean. It has to be less than that. Could it be 5? Well, if it's 5, we could take some from the green and put it into the piece that's missing, and we'd still have too much extra. So it cannot be 5 either. So our mean means that when we're shared up equally, it has to be more than 5, but it has to be less than 32. So we don't know, so let's take a guess. Let's imagine, look at the blue level. So let's say that's the mean, right? That if we shared it up, then everybody would be able to get 14. We'd take out some from the green and put it into where the purple is, and some from the brown and put it there, and hopefully everybody will get the same amount of 14. Let's see if that makes sense. Let's take that green and break it up. If we break up that green 24, then we'll have 14 below and 10 more above. So 14 will carry us to our mean, and if we redistribute it, we take it and share it somewhere else, we can carry it into the first, second, third, fourth, fifth. The fifth basket, let's say, and put 10 of those across there. What happens now? The second basket, let's call it that, has 14, so we're good. The third basket has 14. By the time we go to the fifth basket, well, it's almost 14. It's 5 and 10, 15. It has a little extra. If anything, we could always take out 1 to make it 14. Right? What else do we have to deal with? We have to look at that first one. That first one, 32, is so large. It's so much bigger than 14. So let's break up the 32 into 14 and what number? 18. 14 and 18 will give us 32. And if we take that now, is 18 going to fill that space that we're missing? Well, it's too much. How much do we need in that space? We just need 14 in that space. So we could break up the 18 into 4, and 14 will give us 18, and 14 is 32. So we still have our 32. And now we could take that 14 and carry it across. Now look what happens. If the mean is 14, then the second column is good, the third column is good, the fourth column is good. But we have 1 extra in the fifth column. And we have 4 extra in the first column. So we have more. That means our mean is greater than 14. Let's break up that 4 into parts. So we get 1, 2, 3, 4. So we have 4 parts there. I can take 1 and put it across there. So look what happens. The last row, 5 and 10, is 15. The second to last row, 14 and 1 is 15. Let's take another one and carry it across by the green. 14 and 1 is 15. So we have 15, 15, 15. Only the blue one is missing 1. And when we carry it across, we have 15 there as well. And we left with 1 there. So what does that mean? That when we redistribute it, everybody gets 15. So that means that our mean is 15, and we solve the question. Some teachers say, well, okay, there's another way we could do it. We could consider we have everything all together. Means that we have what? We have 32. And what else do we have? 14. And we have 24. And we have 0. Do I need to add 0? 0 doesn't change anything, so we can leave it out if you want. And we have 5 more. And if we add up all that, let's see, let's add. 4 and 4, 8, 9, 10, 10 and 5 is 15. So I can put the ones from the 15, cross it out, and put it in our answer, in our sum, which is 5. And 3, and 1, 4, and 5, and 1, 6 tens. And if we have a 10 below, we have 7 tens. So that means we had 75 in all, and we need to share it equally into how many? 1, 2, 3, 4, 5 columns. So we can say 5, right? And we're going to share that, our 75, into 5 parts. So if we have 7 tens, can we get a group of 5 from that? We can get 1 group of 5. And what will we be left with? If we use up a group of 5 from 7 things, we'll have 2 left. So what do we have now? We have 2, 5, which is 25. So how many groups of 5 can I get there? 15. So the mean is 15. And let's go to our final question in section 1. And this question is number 20. The incomplete tally chart below shows the pets owned by students. So in the house birds, we have 8 and fishes 10 and dogs 12. And the tally chart shows for birds 5, 6, 7, 8. I've put different colors so you can easily identify them. Fishes 5 and 5, 10, and dogs. Complete the tally chart to show the number of students who own dogs. So how many dogs do we have? We have 12. And when we're putting in the tally chart, we put in sets of 5. So this is the stuff that's missing. Let's go put 5 in there. Does that bring us to what we want for enough dogs? Not yet. So how many more can we add? Can we add another 5? Let's see. 5 and 5 is 10, right? Is that our answer? No, we're missing 1, 2 more. So now we have 12 in the tally chart. So let's double check the question. Complete the tally chart to show the number of students who own dogs. 5 and 5, 10, 11, 12. And we've represented it. What happens now is that we have now come to the end of this particular paper, SEA 2023, specifically section 1. When we started this project, we started with SEA 2019, so you can find this in our YouTube channel, and it's going on up to 2023, 2019, 2020, 21, 22, 23, and our next paper will be 2024. Okay, people, you will take care. Have a good time. Bye.